Loads the dataset, X represents features and Y represents the target. And this code prints the first element of X to the screen. This code prints the first and last elements of Y to the screen. Prints the dimensions of X and Y to the screen. Hides warning, randomly select 16 for images from X and display them in an 8 by 8 subplot in grayscale. Displays the corresponding label above each image. This code creates a neural network model. The input size is 400. The first layer contains 25 neurons. The second layer contains 15 neurons, and the last layer contains 1 neuron. All layers use the sigmoid activation function. Prints the summary of the model, number of layers, number of neurons, parameters to the screen. This code runs unit tests on the model, evaluates the test result. Calculates and prints the number of parameters for each layer, includes W and B parameters for L1, L2, and L3. Assigns the model's layers to variables layer 1, layer 2, and layer 3. This code prints the dimension of the weight and bias matrix for each layer. W1, W2, and W3 are weight matrices, and B1, B2, B3 are bias vectors. Prints the weights of the third layer of the model to the screen. Compiles the model and uses binary coarse entropy laws with the Adam optimization algorithm, then trains the model for 20 epochs with the X and Y data. Makes predictions for X0 and X500 using the model and prints the result to the screen. Evaluates the predict value based on the threshold of 0.5. If the prediction is 0.5 or greater, YHAT is assigned 1, otherwise is it assigned 0, and the result is printed to the screen. Display randomly selects images in an 8 by 8 grid. Each image shows the true label Y and the model's prediction YHAT above it. The images are present in grayscale. A function that computes a dense layer, it takes input data wait macros w bias vector b and activation function g. It returns the values of the activation units as output. Call the myDance function with the test data and prints the output to the screen. It calculates the activation output of the dense layer with xtst, wtst, and btst. Runs unit test that test the myDance function, evaluates the test results. A function that creates a sequential model. Starting with input data x, it calculates the output values using three dense layers, W1 and W2, W3, and their biases B1, B2, B3. The sigmoid activation function is applied in each layer, and the final output is returned as A3. Assigns the weights and bias matrix of the model's layers to temporary variables. Makes predictions for x0 and x500, evaluates the predictions based on the 0.5 threshold, and prints the result along with labels. Display randomly select images in an 8x8 grid. Each image shows the true label while the prediction obtained with TensorFlow and the prediction obtained with NumPy above it. The imaginations are present in grayscale. Transforms the inputs into a column vector and calculates the output by multiply with the first layer's weight and adding the bias. As a result, prints the dimensions of the first layer's activation output. Defines a function to compute a dense layer based on given inputs, multiplies the weight matrix and adds the bias to calculate the output, process the result with the activation function, and returns the output matrix. Creates test data and calculates the dense layer output using the myDance v function. As a result, prints the activation matrix containing three output units for examples. Test the myDance v function, check whether it works correctly. The mySequential function computes a three-layer dense network on an input with given weights and bias value, and returns the output. This code takes the W and B values from the model's layers and assigns them to temporary variables W1 TMP, B1 TMP, W2 TMP, B2 TMP, W3 TMP, and B2 TMP. The code calculates the model's prediction using input data with the mySequential function and display the dimensions of these predictions. The code classifies the model's prediction as 0 or 1. If the prediction's values is greater than 0.5, it is assigned 1, otherwise it is assigned 0. Results are printed for the first and 501 examples. This code display randomly 16 for images in an 8 by 8 grid. Each image has the true label and the model prediction in the title. This code displays the first images that the model predicted. The title indicates the true label of the misprediction and the model's prediction. The image is displayed in a grayscale at a size of 20 by 20. This code adds the value b to the array and prints its shape and content. The output is a 3 by 13 by 13 by 1 array with 5 added to each element. This code multiplies the array A by B and prints the shape and content of the result. The output is a 3 by 13 by 13 by 1 array with each element multiplied by 5. This code creates arrays A and B and prints the shape and result of their sum. Thanks for listening.